Hello and welcome to episode 65 of Daryl Show Your Work. And in this episode, I'll be investigating a potential intrusion here. So I'll be using a variety of tools that I've covered in some of our previous videos here for us to get to the bottom of what's going on to see if there was an actual intrusion and ways we can do to stop it and mitigate any damage done. All right, so to get started, let's go here to the company website, the mock company website. All right, so that's gonna take us to http colon slash slash, and we're going to hd movies.ca. Because we're a Canada-based company today. All right. All right. So now that we're here, um, let's say we want to do some log analysis to really see what's going on as far as the traffic here on this website. So we're not going to use any sort of fancy tools today like Splunk. I'm going to do some manual log analysis. So to get started with that, I'm going to open up my terminal and let's increase the font on this. Let's see, change it to my usual 24. All right. So in order for me to start analyzing that traffic, I need to access the log file for it. So I'm going to need sudo, need some elevated privilege to do this. And then I'm going to say cat to read the file. And then I'm going to go to where that log file is located, which is in var log Apache. We're using an Apache server, web server here. And then the name of the file is access log. And we're going to you look at access log.1. All right. Give it my password. All right. Now we have a bunch of traffic coming from different directions. Just remember, this is a website. So starting at the top, I have to look at any sort of files that don't look like any sort of web resources here. Um, or any usual traffic, since this is a movie downloading site. um, that's what I'm looking for. So right now we look at, I'm gonna zero in on it so we can see that the regular web traffic here is, we're looking at JavaScript files or PHP files, some cascading style sheets down here. But we look at this one particular um, entry here, all right, coming from the IP address 172.20.07, and it looks like this person went to download a packet capturing file that was on our end. How they were able to access that packet capturing file is a good question, but the problem with this is they will be able to see our internal packet capturing and go through it and analyze it for themselves to look for any sort of open protocols or any sort of vulnerabilities that may be indicated within that packet capture. All right. So the next thing we need to do is take note of this file, and we want to be able to download this file on our end to see basically what the potential this potential attacker could see. All right. So bringing myself back down here. All right. So first we need to get a hold of this file and then analyze it. So to get the file on our end, I'm gonna do wget, and I'm gonna just simply put in the URL of where we would get where we would get the file, we're suspected where you will find this file, which this is a problem, as you'll see as I type out this web address of why it's a problem. All right, the name of that file is dailytraffic.pcapng. And as you can see, this is publicly accessible from the front facing web server. Okay, so this is something that an attacker, no one should be able to go and type in the name of a file or an internal file within a URL of our public facing URL and be able to get a hold of something internal like this, like our daily packet capturing of traffic. Okay, so that gives us an indicator of how it is that our attacker was able to get a hold of these files, because we left a directory open that should have never been open to the public. So I'm gonna hit enter to get this file to see if my theory works here. And let's see, make sure I put that URL in correctly. Let's see, HTTP. Oh, forgot a slash here. Okay, I was trying to figure out what was wrong with my syntax. All right, looks like my theory was correct, because we were able to go straight to that directory and download that file to our system. So that tells us how it is that our attacker here at that 172 address, how they were able to get a hold of this packet capture. Now we need to see what's actually in this packet capture to see was there anything potentially sensitive or interesting that the attacker may gain knowledge of. All right, so I'm going to use Wireshark, since this is a packet capturing file, and I'm going to tell Wireshark to open up this file. So we're going to open Wireshark. We're going to open Wireshark up directly to displaying the traffic that's captured here in this file. All right, so that's going to start Wireshark up for us. All right, so let me just maximize this for us. All right, so we can already see we have some FTP traffic and we have some HTTP traffic. The problem with this FTP traffic is it's a clear text protocol. So there's a good chance that if some sort of connection was made, some sort of FTP connection was made during this packet capture, that the attacker could possibly see, some clear text credentials, and we want to be able to verify that. So I'm going to apply a filter to only show um, FTP data. I'm going to say FTP data here. All right, and what this is going to do is going to isolate the packets belonging just to the data channel for this FTP session that we see going on right here with these addresses. It's 172.20.0.2 and .9. All right, so we just want to isolate those. So I'm gonna hit enter. All right, so let's take a look here at this first packet. I'm gonna right click it, and let's follow the packet to see if we can find anything that may be interesting that the attacker may have seen. And yes, we do find some interesting things. All right, so we can first see a clear text username here with admin. All right, so one less thing that an attacker would have to figure out. They wouldn't, as far as enumerating any sort of credentials. Well, they have already have what looks like an admin account user a name here, and now all they would have to do is take this hash, all right, and see if they could be able to crack it to then be able to deduce what the password is, and now they have both a username and password to use, and as far as trying to authenticate to some host within our network. So I need to say, so I want to be able. The next thing I want to do is I want to save this file, and I want to see how easy it is for me to try to crack this hash here, because if it is relatively easy for me to do it, then it will probably be relatively easy for an attacker to do it as well. All right, so I'm going to save this as, we're going to call this leaked underscore hash, and I'm going to save it as a txt file, and I'm going to save it to our local directory, home directory here. All right. So I'm gonna open up a new terminal window, and the next thing that I want to do is I want to be able to try to crack this hash. So I'm going to use the John the Ripper application in order to do this. All right. So, and let's just make sure that everything is in our directory where it should be. All right. So we can see the daily traffic a pcap file, which of course we verify is there because we were just looking at it, and then also the leaked hash txt file that I just saved here with that password hash in it. All right, so let's get started running John. All right, so I'm gonna tell John, try to crack the file leaked hash.txt. All right, and I'm gonna tell him to use the word list. Let's see, it is located at user slash share slash word lists, and the word list that it's going to use is its default word list, which is rockyou.txt. All right. All right. So just checking my syntax here, just making sure everything's set up to work correctly. All right. So let's try to crack this hash, and let's see what happens. All right. So, well, it gave us back. It looks like it gave us back that it was able to crack password. It seems like it's indicating that it's admin, that it's admin as well, but let's verify this. So I'm gonna say John dash show leaked hash dot txt, and bam, it verifies that for us. So we have admin and then admin. So username and password. All right. So we have a pretty weak credentials there. So given the ease to which I was able to crack the password, I think it's safe to assume that the attacker was able to as well, using a similar methods. So let's verify this and see if the attacker used the credentials to gain access into the internal system. All right. So in order to do this, I'm going to check all the running services for any potential point of entries. All right. So it's going to, by writing this command, it's going to give me all the current protocols that are running. So I'm gonna say service dash dash status and dash all. All right, so anything with a plus next to it means that it's running. Anything with a minus next to it means that it's not running. So let's look at something that could be potentially dangerous here. Let's look at SSH, since we could clearly see that that has a plus sign next to it. Let's see if there was an SSH session made. So in order to do this, I am going to then look at another log file here, and I'm going to look at the log file that's going to display all the latest established connections. Sorry about that. I'm going to go to cat, and the log that we want to look at is located in var log, and it's called last log. All right, and we can see that. Look at it. There's our buddy at 172.20.07. This is the same person that downloaded that file. And let's see. Let's go back to Wireshark to the traffic here. I want to take a look at something. And I don't see yet. No, it wouldn't be. He wouldn't be here in the history because this was from a past FTP session. But we can see that this is the same person that downloaded this PCAP file to begin with in the initial log analysis that I did. All right, so we can see that our attacker did make a connection here to our internal system. All right, and so the next thing that I want to do is I want to be able to look for some sort of indicator of persistence. All right, so see if there's any sort of weird looking processes running at the moment that would be an indicator of any sort of persistence mechanism. All right, so in order to do that, I'm going to run a command that px-aux. All right. And so that's going to display all the running processes. And again, I'm doing this to be able to find some type of indicator that some sort of backdoor or something would be running that would allow the attacker to maintain persistence into our system. All right. Quite a bit of process is running here. All right. So I'm gonna just kind of scan through here. Oh, no need. Something immediately caught my eye here. So if we look at our process ID 2171, all right, we can see that we have a netcat listener running. All right, and it's looked like it's in listening mode, and it's listening on port 322. All right, and it's executing at bin bash. So what that tells us is that this is going to allow the attacker to interact with the bash session on our end, which we don't want them doing that because then that allows them to run commands on our end. This tells me that the attackers are using this port to connect to the machine persistently. This 22.3.22 port. All right, so uh, the next thing that I need to do is I need to I'm going to use a tool called ACK, and not in terms of the syntax at the the three-way handshake, but it's a tool, and I'm gonna look through all the system files to find which script or process is initiating netcat here. All right, because we want to be able to cut it off at the root and to stop this process from running. All right, so in order to do that, I'm going to say act dash nc. I'm gonna give it the whole everything that's going on in that process. All right, so all the flags, and then the port, and then the execute portion of the command, and then the location of which is executing, which is bin bash. All right, just so checking my syntax here just to make sure everything is okay. All right, I'm gonna hit enter. All right, so this, if we look up here in the green, it's telling me that it's actually the bash rc file that is that's executing the netcat script. All right, so um, um, this is the script that, yeah, I mean, this is what's causing it to happen. All right, and this is typically the script that's used for the to establish a bash session in the Linux, in the Ubuntu distributions. All right, so the next thing I want to do is I want to verify that that there's something going on and that this file has been modified in a way to initialize that. I want to be able to go in and verify that, and then I also want to be able to remove whatever line is in within this file that's causing that to happen. All right, so in order for me to do so, I'm gonna use my text editor, and I'm gonna go into this bash rc file. All right. So I'm going to save us some time, and I'm going to just go straight to it, which is it's all the way in the bottom of this file here. All right. So we're not just looking through lines of code here. All right. So I'm at the bottom. All right. So we can see it right here. So nc dash nvlp. All right. Those are the parameters, and we can see that it's the port that's listed on, and that execution command, and then the location in which is it's executing the command, and it's which is from the bash directory. So I'm going to delete this line of code, and this should stop this should stop this from happening moving forward. All right, and I'm removing that from here, and that should get rid of this attack vector for the time being. All right, so I'm going to Control X and then yes to save. All right, now just because we've gotten rid of that doesn't mean that we've eliminated the problem. Now I need to actually terminate the process going on right now, because clearly the attacker is still in our system. So I need to be able then to end this process that's currently running now, because all I've done is stop them from using it again. But let's kill the process that's happening now. Remember that process ID is 2171. So I'm gonna just simply write kill 2171. Oh, not 72, 71. All right, looks like that went through. So I can what I can do to verify that, I could just say sudo netstat and put in the following parameters here. All right, and this is going to show me all the current connections coming from the internet. All right, gotta give it my password. All right. So if we look at the process ID, that process is not here. That 2171 is not here. And again, these are active internet connections. So we can see that there's no one from the outside, and there's no well, listen, there's no 2171 PID anymore that's connecting to us through that SSH connection. All right, so that brings me to the end of my video here. So just to give a high level overview of what I accomplished here, I started off by conducting a manual log analysis to find any sort of potentially malicious actions going on within our web traffic, and that's where I found the downloading of this PCAP file, which was publicly facing, should have never been publicly facing. All right, and then so I downloaded that file for myself, and to then jump into Wireshark and see exactly what was in that packet capture, and discovered that it had some FTP sessions, which is a clear text protocol, which is another red flag, because then an attacker who knows what they're doing could go in and be able to see some clear text credentials, which I was able to verify was present in terms of that admin username, and then also a password hash. So I tested to see how easy that password hash would be to break using the John the Ripper application, and I was pretty much able to crack it within a couple of seconds because the password was something as weak as admin. So we have an admin credentials. So I figured if it was that easy for me, it would be that easy for our attacker. And so then I went and I basically saw if there was any sort of connections established that may be using those sort of those credentials, those clear test credentials that were found, and we found that that SSH was indeed in operation, and there was a connection made by the same IP address that downloaded the that PCAP file in the first place. So we know that person is in our system now. So I looked at the active processes and saw that there was a netcat listener going on, listening at a underutilized port within our network, and that it was executing that listener using the bin bash directory, and then due to some code that it entered in, a line of code that it entered into the .bash RC file. So I went into that file. I got rid of that line of code, and then from there I terminated their current netcast listener session to fully get them out of the system. Now it doesn't end there, because then we need to remediate the issue with that that PCAP file being available to the public. Okay, there's some other ways we need to harden our attack surface here, but that's the extent that I'm going to show in this video. So please like, subscribe, and share. And as always, share your work. And until next time, take care of yourself, and God bless.